Hi, everyone. Thanks for joining us today. If you're looking to improve Postgres monitoring and observability, you've come to the right place. My name is Kirsten Foon, and I'm part of the marketing team here at Percona, and I will be your host for today. I'm joined by Charlie Batista, our Postgres tech lead, and Agustin Gallego, our senior support engineer. They have extensive Postgres experience and are here to share their knowledge with you. I am also joined by Nikolai Ehalainen, our senior escalation support specialist, who is here to answer any additional questions. Before we get started, we do have a few housekeeping notes to go over. All lines are on mute for the duration of this call. Questions can be submitted at any time through the Q&A panel on the right side of your BrightTalk console, and that's where the little question mark is. We'll get to as many of them as we can at the end of this session. And for any questions that we can't answer, we will create a blog post to address them. This session will be recorded and will be available for replay afterwards. And with that, I'll let Charlie kick it off.
Oh, thanks, Kirsten. Hello, everybody. It's a pleasure to be here with Agustin, my colleague at Percona. So today we're going to talk about monitoring. Well, let me start sharing my screen here. I suppose everybody can see my screen, right? So today's talk is how to improve Postgres monitoring and observability with Percona monitoring and management tool, what we call PMM tool. As said, my name is Charlie Batista. I'm the Postgres tech lead at Percona. So I've been working with Postgres for quite some time right now. And we are also been working with monitoring and observability. I have here with me Agustin Gallego. He is one of our senior support engineer and is very versatile in both Postgres and also monitoring and PMM. So that said, this is going to be our agenda today. So, today what we're going to tell what is Percona, what is PMM. So Agustin will going to explain to us what is PMM. Going to show a little bit about PMM's interface. Then I'm going to jump in and talk about metrics. How can we use the metrics that PMM can give us to troubleshoot query performance? How can we get some OS metrics? And also, how can we analyze the Postgres metrics inside of PMM? And one of the things that I really love on PMM is because it's a very customizable tool. And Agustin gonna talk about customization. He's gonna show us a couple of examples how we can customize the tool, how can we improve and add some metrics that is not by default and we might need on PMM. And we hope we have time for a live demo, and we hope the live demo works because, well, live demo, they usually bring us problems. But we do hope that we can go through this time. And if everything goes well, we're going to have a couple of times for questions by the end of the presentation. Well, that said, I'm going to stop sharing here, and it's with you, Guli.
Thank you, Charlie. Let me share my screen here. And here we go. Okay, I hope you're seeing the screen. Let's go over briefly what is PMM, how it is composed, and the architecture, so we can be more familiarized with the tool we have at hand and we can take the most out of it. The first step with every tool you use is, of course, knowing how to get the information that you want from it. Okay, so PMM, as Charlie said, is, in short, we always say PMM, is a monitoring tool built on top of open source software, right? So we have a lot of layers of software involved in here, which we package into one container in the case of Docker to present all in a uniform packet that you just need to install server and client, and you are ready to go. So what are these different layers we have? So Grafana is used for visualizing and is what we are going to see mostly running in the user interface. And then we have Victoria Metrics and previously Prometheus until version 2.12. The difference with Victoria Metrics and Prometheus is that basically Victoria Metrics allows everything Prometheus does and also be able to push metrics from the clients. So when we discuss a bit more of the architecture involved here, we are going to see what is the benefit in this particular case. Then we have ClickHouse for storing the internal query analytics related data, PostgreSQL for storing configurations, and then we also use other tools like Nginx, Alert Manager, etc. But this is just so you get a taste of what we have going on within PMM itself, all the tools that are made to interact together to help us get the functionality we present in PMM. Okay, so out of the box, we have support. You are all, of course, here for PostgreSQL, but in this day, it's not hard to find environments in which many other different kinds of databases or database systems are working together. So you can also have MySQL or its forks like Percona Server and ConnectXtraDB cluster, and you can also monitor these out of the box with PMM, right? So Postgres, MySQL, and Mongo are all supported by PMM, and they are expected to work with the same ease of use as with Postgres. So let's discuss a bit of the architecture behind PMM. PMM is a client-server, follows the client-server architecture. So we are expected to have one component of it being like the center of all the metrics and queries, and then around it, all our clients which are going to be running within the database server itself, exporting metrics to the PMM server. Okay, if you're wondering, okay, what if I have RDS or if I cannot install a package in the database server? Well, we also have what we call the external exporters, that they are able to run outside of your database server and collect metrics externally. In the case of RDS, for instance, this is going to be collected from PMM server itself using functionality that we have designed for it. But yes, the first step in understanding PMM is that this is a client server model, and that you are expected to have these kind of two layers in your environment. Okay, a dedicated server for PMM server, and then nodes that will export data. In here, we have a small diagram that shows all the components that we were discussing just now, like Nginx, ClickHouse, Postgres, Victoria Metrics. And in here, we have what I was referring to before as the push versus pull model. If we had Prometheus, as we had before, we would only be able to pull metrics from the client, because Prometheus doesn't support anything else. This means that on the PMM client, you would have to have the ports exposed or open to PMM server, and it's not desirable in every case to do so. This may be a security hole, right? So in this case, if you are using Victoria Metrics, which with any latest version you are going to be able to only have the needed ports, the minimum amount of needed ports in the client, and on the PMM server, of course, you will have to have port 443 for HTTPS. But this takes down the needed ports to a minimum. Okay, so yeah.
Just a second. They're asking if this is being recorded. Yeah, it's being recorded and will be posted on the social medias later on.
Yeah. Okay. Now let's go. Let's move forward and discuss a bit PMM interface. Let me check the time. Okay. So the second step in making the most out of PMM is knowing how it is displayed, how metrics are displayed within the different dashboards. So to understand this, we have to have a knowledge on what is a metric and what is a dashboard and what they are used for. Basically, they are three levels of information or how we can aggregate information, right? So metrics are our most atomic measurement. And this is just one thing we want to measure at a specific time, right? We are going to see later on how PMM has different metrics resolutions, and that means the amount of time that every metric is polled, right? So we can have by default the there are three different levels, and it's the high resolution, the medium resolution, and the low. And by default, it's the high is 5 seconds, and then you get 10 seconds and 30 for the others. And then these will be used in the graphs, right? So our atomic measures are the metrics, and we are going to have a lot of metrics together composing graphs, which can give us um, a, a more broader term of what we need to read from PMM, right? And we are going to see some examples in particular that are going to make this more evident, right? So graphs are basically metrics grouped together, and then dashboards, they are even a bigger abstraction, and they are going to be graphs grouped together to, for example, we have the OS dashboard and the PostgreSQL dashboard, right? So these are going to be two different stories that our metrics are telling us from our server. So this is the home dashboard. When you open the PMM server URL, you're going to be presented with the home dashboard, with in which you, if you scroll down, you will have an environment overview, which will let you, with like a kind of a bird's eye view, tell the state of your different nodes at the latest 12 hours by default, right? So you can change at the top here, you can change, I will show you now in a bit, but you can change the amount of information that is going to be grouped together in all of these, right? In this case, it's last 5 minutes, by default it's 12 hours. So you can really get a good sense of what is going on in your environment just by looking at this initial dashboard. If you need more information from any server instance in particular, you can then go to the in the quick access, you can go to the different levels of dashboards that we have. Remember, I was saying before, we have like the OS dashboards would be system, and then the PostgreSQL dashboards would be under PostgreSQL. So you can just quickly go to the PostgreSQL summary and then just select an instance and move straight to it. If we, let's say, if we went to the PostgreSQL instance summary, we would have again another navigation pane that we can use to change within Postgres itself or within the other, like the OS summaries and the other databases that are supported. We also have that Charlie will show you in more depth very soon, the query analytics dashboard, which is the one that is in charge of collecting all query related information, right? In PMM, we have two big, let's say, categories of data or information. One comes from queries themselves, like the SQL text and the related metrics to that, for that query or that family of queries. And then we have metrics, which they are like isolated, and as I was saying before, like the atomic data for our server. So then in here we would see the dashboard is all of this and if we keep scrolling down, we will see more graphs, but this is the dashboard, which is a group of graphs which are indeed a group of metrics. And maybe I should, yes, let me move real quickly to an example in particular so I can maybe be a bit more clear. So let's navigate to the PostgreSQL summary. Let's select the primary node and let's select last, I don't know, 30 minutes. Okay, so the dashboard is all of this, which is, in this case, the instance summary is supposed to give us again, a bird's eye view from our PostgreSQL metrics for this server. Okay, so as you can see, we have many graphs here, and even some of these graphs have many metrics themselves. You see, so this is how we go from top down and from bottom up in terms of data aggregation and how we can view the different status and metrics from our server. Now, Charlie, sorry, will move forward with showing the query analytics functionality and some metrics we can get from PMM, so we can start moving forward with, now we understand how to use it. Now we need to just start using it and solving issues with it. So Charlie, back to you. Let me stop sharing this.
All right, thanks, Agustin. Let me start sharing here. So what you're gonna talk now is a little bit is how to use some of the information that you can get from PMM to start troubleshooting problems. One of the most common problems that we usually have on the database are related to queries, performance on the queries. And as Agustin was talking about, we have this dashboard that we call it QAN for short for Query Analytics. So this is the dashboard that we have here. So we have main information by default on the dashboard for the queries that we have, the query that's been executed to the database. Some information about the load that is being caused into the database. And also the count, the query times, and some information that we can have for the query itself on the database. I'm going to show you in a bit how we can start adding or removing some information that we have here from this dashboard. For Postgres, it uses, you can use two main source of information. PG start statement is at the moment is the default one. And also can use PD Stat Monitor. That's an extension being developed by Percona to enhance the information that we can collect from the database. It's very advisable to use PD Stat Monitor because it's being designed to expose more information for Postgres, and it's being designed to cooperate even better with PMM than that information that we have with PGStat monitor, with PGStat statement, sorry. Some information that we can get are the time interval grouping. We can get the query plan that is being collected for the queries, and we can also get the histogram. And you may ask, how those might be useful to analyze information, right? Let me jump here for the histogram. That's one information that I really like, very useful and powerful when we're analyzing a query on the database. We can see the distribution of the time that is being executed. So we can have a sense of how is being distributed that query over the time. And that help us to pick the queries that give us more trouble in the database, the query that execute during the largest time. So we can use the 80-20% approach. So we get the 20% of the queries that cause the 80% of most trouble that you have on our database. With this approach, we can spend more time, less time troubleshooting, and we can get a better improvement, right? Let's see how does it work here. So I do have here my PMM, as you can see here. Let me go here for the home dashboard. So this is the home dashboard. This is what we see when we log into PMM, right? So we do have a shortcut here on the top right to go for the query analytics. It's going to open here my query analytics. I'm going to choose only my primary. because it's most of the load that I have here are from my primary. I almost have nothing here on my secondary. And I want to see here, I'll pick whatever one query here to see what kind of information we can get. Right, for example, this one here. So in this example, I'm using pg stat statement. So I can have normal information of the queries per second, how many queries per second is being run here. I can get some information from the table that's been executed. Like here, just at the click of the mouse, I get the columns for the table. And we can add a couple of columns here. So here, as we can see, it's showing me the query count, how many queries per second, the query time. So it's nice. But what if I want to see how many rows being returned? I can check here what the columns we can add to the query analytics. As Agustin mentioned, PMM is designed to be a very extensible tool and to work with multiple databases. And here we can see, for example, that we have this information that's for MySQL. We have a couple of informations for PostgreSQL here. And we'll see that we might have some information that are for both. Like, for example, the one that I said, row sent. We can get for both MySQL and Postgres. And here, I can see, for example, that this query here, this update, is being sent 11.76 thousand rows per second. So if I want to optimize my database, one thing that I really would like to know is how many rows one query is being sending through the network every second. So if we see that many rows is being sent, and then later on we can check if we have more than one client connected and sending that many rows, or if a client is sending 11,000 rows per second, something might be wrong with the client. So this is an indication that you might have a very bad query being executed by the client through the database and pushing the database to its limits. So this is definitely one query that I would take a look. I'll check if something is going wrong. And we have a lot more information here. And this is just looking at the query side of the database. We also have other metrics. Let's move on a little bit here. For the other metrics that we can check, or the OS metrics. I'm going to jump for the database metrics as we're talking here about the query analytics. I'll come back to the OS metrics later. So as I said, we've seen here that we have a couple of queries that are sending quite a lot rows per second, right? So one thing that we can do is we can go here for the database. If I go here on my dashboards, I want to choose PostgreSQL. I want to see my Postgres summary. Okay, I have some not nice red notes here. I need to choose my primary. And looks like, okay. And here we have. So this is the summary of my primary. What is happening on my primary? As Agustin explained, we can check here what is the time range I want to analyze. Well, for now, I'm gonna stick to the 15 minutes time range. I want to see what's happening on the 15 minutes, but I want to be updated every 10 seconds so I can get some new metrics every 10 seconds here. And remember, I was seeing that some queries, they've been sending a lot of data, and this is exactly what I can see here. I can see on this graph that I see that some tuples that have been returned are around 17,000 rows per second, and 10,000 rows being updated, and 3.4 thousand rows is being inserted on my database. Well, I have some load here on my database. If you pay attention on top here, I have some information about my database. So I have 8 gigabytes of shared buffers. I have the uptime here. I have a max number of connection that's 1,000. This is the configuration for my database. obviously, I'm not getting 1,000 connections here. I'm getting a lot of less. But if I see here, for this configuration that it can accept up to 1,000 connections, well, that's not good. That's definitely something I would take care of. I'll try to change and talk to my developers and really ask if they need that many connections. Well, maybe the application does need a lot of connections. And one thing that we can do is to put a load balancer, a connection pool in front of the application. So we can save that some of those loads. And we don't hit the database with that many. Even if we are not hitting with 1,000, that's quite a lot here. So we can see that from time to time, we have a peak of 250 connections. For this machine, it's quite a lot. So it can cause quite a lot of problems. And we can navigate here and see everything what's happening on the database. For example, I can check here the duration of my transactions. And I see that from time to time, I have some peaks here. So some transactions, they take up to 150 milliseconds or even 200 milliseconds. Well, it's usually not a problem. But if my application is sensitive to the load, it can become a problem, especially when the number of connections start increasing. And let's try to do something here. Let's try to increase the number of connections here. I have a load running. I'm just stopping the load. So when I stop at half of the load, we can see here in a second that, see, it's just dropping here because I stopped at half of the load. But now I'm gonna just increase the load. So I'm gonna double the load that I have with the double number of connections. And we'll see the impact that it might have to my database. How rising up the number of connections that we can see here. Well, in the beginning, we can get a larger number of tuples, but then we'll see that the number of locks, they will increase quite a lot. Before, we were having around 1,000 locks on the database. I mean, all the logs, all the counts of logs. And here, we are up to 3,000. So eventually, when the buffer started to be saturated, the number of rows being returned, they will start dropping. As we can see here, see, they started dropping here. This is what the number of tuples we had before with half of the number of connections. Now I have doubled the number of connections, but the throughput to the database, they going down. As we can see here, increasing the number of connections is not necessarily a good thing for the database, because now I'm causing a lot of contention to my database. So we're just checking for the database point of view. And one of the contentions that we have are the number of locks. We also have here, we can see the transaction time, the average, it's been rising up. Remember, it was up to 200, and now we have a transaction that is close to 400 milliseconds. And if I keep the load, as the caches and buffers, they've been filled, things gonna get quite worse. And the number of transactions per second is gonna go quite down. And the only thing that I did was doubling the number of connections. Before I was with around 200 connections. Now I'm probably around 400 connections here. See? And yeah, 400 and peak of 600, but around 400 connections that we have here for my database. And it's clear from the information that we get here from PMM how prejudicial, how problematic this approach is, just increasing the number of connections. And this is how we can use the tool to start troubleshooting problems. So I can clearly see here that I have a problem on my database. And I know that the problem is the rising in the number of connections. So because I did it, and also because I have this peak here, and if we start analyzing from this peak, everything went quite badly after this rising in number of connections here. But why is this a problem? Well, we can now move on to the next one, that is the OS metrics. So we try to find some reasoning why increasing the number of connections is so problematic for the database. And we can get quite many informations here from the OS metrics. So here we have mainly well, as the name implies, the metrics from the operational system. So I have a summary here from my operational system. So I have 300 gigabytes disk space. I do have full 62 gigabytes virtual memory, but do not get full because my RAM actually is only 32 gigabytes here. 2 gigabytes around is like for rounding is not being shown here. So that's normal. And I do have 8 virtual CPUs. So it's a box on AWS with 8 CPUs, 32 gigabytes RAM, and around 5 gigabytes disk space, but I'm only using 350 gigabytes here for the database. Disk space is not a problem. So we can see here that with the load that I have, I will take ages to run out of space. So I'm not concerned about disk space. But I can see something in red here. This is the load average. So this is PMM telling me that something is going wrong with my CPU. So my CPU is being stressed too much. If I go down here and see the CPU usage, I can see they have quite a huge usage. But that's not the main indication. The indication when you come to the saturation of my CPU and the saturation of my process here. So it's not all the times there is a problem when our CPU gets close to 90 or 100% utilization. Having 100%, like close to 100% utilization CPU in the box just means that we are using the CPU up to its power ups that we have. And it can be a good thing, right? If I have my database, I would like to use quite close to all the resources I have on my database. So I can save some money on the infrastructure. The problem is when I start saturating my CPU. And for example, in this example here, I only have 8 cores. If I'm open 400 connections, every connections needs to be handled by one CPU. So just doing easy math, we're gonna have around 20 gonna be 160, 40. So around 40 threads or process per CPU. And this is exactly what this is telling us here. Every single CPU needs to handle a lot work, and this is what is stressing our server here from CPU perspective. But CPU is not everything. We also have other problems. Well, for example, IO activity. So if you say here, I can tell that, well, IO activity actually went down. It didn't increase much the IO activity of my server. Why is my server slower? And why I'm saying that IO activity might be a problem if it's actually is reduced. Well, it's being reduced because the latency to the disk we're putting to the disk is quite high. And those measures, they sometimes are misunderstood. So the number of IO per second is sometimes not the most important information that we need for the disk. We need to know if we have latency on the IO subsystem. The more latency we have on the IO subsystem, the more the CPU has to wait, and the less work the whole system is able to do. Even if we can put a lot more IOs per second, they still have to wait. It doesn't matter if I can put 1 million IOs per second on my disk if they have to wait 1 millisecond every time. So, and because we are causing quite a lot latency, we're putting a lot of loads here, our CPU has to wait a lot for the disk. Everything is being downloaded, has to wait. It's been downgraded. So we do have a lot of pressure here. Okay, I'm gonna just stop my load for a second here. It will take a couple of seconds, couple of minutes probably for things to go back to normal. All the buffers, they need to be flushed and everything. So, but we will eventually see, this is what I mean. This is the OS is like breathing a little bit for, thanks goodness. Now I can flush all those cache and buffers that I have here, and I can go back to normal. When we stop at that huge pressure that we're putting to the database, to the OS is thanking us here, and now the latency is going down. It's flushing, it's able to write a lot more to the disk, and even writing more, the disk loads is going down because the latency now is under control. And this is all the things that the problems that can be caused when we start stressing too much, over stressing our database. And we see the CPU is going down here. If we go back here, okay, let's wait for it to update. We see the number of connections here went significantly down, and the throughput is start increasing. Funny, right? Now I have less than a half of number of connections, and my throughput is going up. It's funny how putting less pressure on the database, how letting the database doing its work make it a lot faster. And this is just a quick view, but it's a quick overview how we can use PMM to help us troubleshooting those problems. There are a lot more that we can do, a lot more we can go over, but like we have just 1 hour here. And I have to go back to kick back to Agustin, or else he's gonna kill me. He still has a lot to show you guys. He still wants to teach us how to extend PMM. It's on you, Gully.
Thank you, Charlie. Let me share the screen again. And I think it should be this one. Yes. Okay, so after all that Charlie has shown us, let's say that there are still things that we want to get from PMM that we are not getting. And the idea of PMM is not to be the ultimate source of truth, but just to be another tool that you can use to get what you need. So we've had in the past, while the tool was being developed, at some time in parallel, you would get new functionality in this customizable way, which then we would bring to, let's say, to the upstream. So it's not only a matter of having flexibility, but it's also a matter of doing like you can do a quick proof of concept with this, and then if things are working as expected, we can then integrate it back to PMM. So it's also a way that you can have to show us, say, look, PMM is missing this functionality. I have been using this script and it's getting me the information I need for X and Y, and I would like to have this in the upstream PMM. So we are providing two ways of extending the available metrics we have in PMM. One is by using the custom queries, and by this is just you would only need to know how to get data from the database with the query itself. So just an SQL query that you can get from Postgres that will show you whatever data you want as a result. Okay, in this case, we can have labels and metrics. Okay, so we can expand that knowledge even more. I will show you an example in particular. And then another, this is more powerful, but it's also more complex to develop, is the text file collector. The text file collector is just PMM being able to extract information from any file that is conformant to the Prometheus definition of the metrics file. Okay, so as long as we are using as long as we are giving PMM a file that can be parsed through this Prometheus file definition, we are going to be able to extract metrics and labels from it also. Okay. Custom queries, as I'm saying there, is they are defined in YAML files, and we are going to check now exactly how we can define them and where those files live. As with everything in PMM, we have these customizations are possible to do in high, medium, and low resolution, depending on what, depending on many things. Actually, it's like there may be more complex queries or more complex scripts that you may want to run only in sparse times. You don't need to have information each second, and or the computation is hard to get, or difficult for the database to process. Okay, so there are a lot of considerations that come in mind, but the easiest way to approach this is, okay, what kind of load will this script or this query introduce into my database? If it's a high load, you wouldn't want to do it with a high resolution, because it can potentially run every second, and in many different instances. So this could be problematic if it's not handled correctly. So by default, if you want, if you want to do a proof of concept, you can use the low resolution, and then only then move up if you think you are missing definition from the metric resolution. Okay, so let's check an example of what we did some time ago. This is if you're familiar with MySQL and with the MySQL dashboards from PMM, you're going to find this very similar. This second half, and these are the amount of bytes that are being written to the write-ahead logs in Postgres, right? So what are we doing here? On the left hand, we have the checkpoint statistics on how many writes are happening because of a checkpoint, basically, right? So we can see here there are two different levels of metrics that we can use here. The first one is the checkpoint timeout. This will tell us the current checkpoint timeout at any point in time, right? So we can see here that this we should be checking the right, and I apologize if this is not, can I zoom in? No, if this is not big enough, but here it says the right y, which is we should use the right y-axis for getting the metric data. So this is 5 minutes. Okay, so the checkpoint timeout was 5 minutes throughout all of these times, but as we can see here, this is like in this 2 minute span, we had done a lot of checkpointing, right? So the checkpointer had to be called 1, 2, 3, 4 times, right? In the span of 2 minutes. We would expect to see one big spike of checkpointing every checkpoint timeout, right? This means that our wall size, so our max wall size, is correctly optimized for the workload, and we are not incurring into unnecessary checkpoint calls or flashing, right? And on the right side, what we can actually see is the max wall size defined, and in this case, this was 1 gig, and the wall writes per checkpoint timeout block of time, right? So in this case, we were having around what is the max? Yeah, 6 gigs, 6.8 gigs for every checkpoint timeouts, so every 5 minutes, right? And this means that we were having to do unnecessary checkpointing with all that that takes, right? So this graph would actually help us in getting a more appropriate number for our max wall size, which we did, and in here we can see the changes, right? So we said, okay, let's increase the max wall size to 12 gigs, and let's see what happens. Okay, and then the write workload in this period of time remained mostly the same, but look at what happened with the checkpointing. We are only doing one big checkpoint, sorry, at the desired 5-minute time lapse, right? So we have changed our workload to be write intensive, like in many short bursts that will slow insertions, to just doing one big checkpoint every 5 minutes. Of course, Postgres internally will handle this better than just doing a big chunk of checkpointing, but this is just how to illustrate what how can we change what Postgres is doing. In this case, for optimizing the wall size, what we used was the text file collector, which, if you remember what I said before, is like the script kind of functionality, right? So what we will have to do here is just we create our own script that generates our own Prometheus metrics file that then PMM collects. So very basically what we're doing here is we are getting the current wall LSN at the start of our script, and then we are iterating in a loop. And since we are going to write this, I'm not showing this here. This is not the best example, but this is going to be collected from the medium resolution. So we can do we can sleep every 10 seconds, and we don't need to be constantly polling Postgres for this data, right? So then after we have the initial LSN, we wait 10 seconds, we take it again, and we use the PG wall LSN diff function to give us the bytes that have been written in this amount of time, right? And then what we do is we generate a file with these Postgres, not Postgres, Prometheus convention of metrics writing, right? This is just metric name, any labels we want, and in here we have to name it the same as the primary PostgreSQL node that we have in PMM, and then the bytes that are written. Okay, this is going to be written to a file, which again, this is not the best example. This is the file that is going to be written to. User local Percona PMM2 collectors, text file collector, and medium resolution, and then just whatever name you want and prom. Okay, and this is the file. As you can see, is very simple. If we chose to remove the comments, it would simply be a one-liner that will be overwritten with the current wall bytes. Then PMM will get this information, will send it to PMM server, and it will store there forever, right? So we don't need to worry about this being a series. This can be overwritten. Okay, so this is like I hope it's clear. If not, feel free to do any questions you have on this. But I hope this is able to show you how the interaction between the text file collector and your own script should work. And then we had another example, which was easier to do with the query collectors. Okay, so this was just showing us the replication lag from the primary to its replicas. Okay, and in this case, we just let me show you this first. Okay, in this case, we just use the query collector, and I will show you these directories now in a more clear way. And what we are doing is writing to high resolution, because we do want to have these every 5 seconds or 1 second if possible. We want to be able to react as fast as possible to very high replication lags. And what we are doing here is just in this YAML file, we are adding our query. That this is just your typical replication lag query that is getting data from pgstat replication, and we are getting the application name, the client address, the state, and the bytes, like the replication lags offset in bytes. Okay, so as I mentioned before, all of these are labels that can give us a better sense of which is a node that is lagging, which IP address, and in which state it is, and then the proper or the byte lag that we are going to be consuming from this query. Okay, this will give you a graph somewhat like this, in which you can use, for instance, in this case, I used the IP address as a label, so we can note which replica was having issues at that time. Even more, we can use these custom metrics to feed our integrated alerting system. Very briefly, it's not, let me check the time. Yeah, it's not the purpose here to show you integrated alerting, but what we can do is even alert on replication lag, which is a feature that PMM didn't have to begin with. And we, by taking all these pieces of the puzzle together, we are even allowed to alert on metrics that are not currently in PMM. Okay, and then the last example is, we will leave you this link here for you to check. This is some work that Sergey has done on extending PMM even more through query the query collector, and creating custom dashboards that will give you more information on tuples, table size, auto analyze, and stuff like that. That is really interesting to have from your PMM instance. I think we're at the top of the hour now, so let me briefly show you the directory. I will have to stop this. And let me briefly share my terminal so I can show you. Oh, well. I think you have to bring it here. Give me a second. Window terminal, yes. So this is our primary node, and you can use PMM admin list to check the current status of your different exporters, right? So in here we can see that we have the node exporter, which is in charge of exporting OS metrics. It is working fine in push mode, as we were saying before. And then we have our PostgreSQL exporter, which is running in push mode. Okay, so if we want to augment what we already have, we just go to user local Percona PMM2, and then we have in this subdirectory we have the exporters and the collectors, right? In the exporters, we left all our custom exporters that we use for this, like the wall size and the exporter for the replication. And then in the, let's go to the collectors. In the collectors, we have these two directories, right? In the custom queries, we are going to be able to modify our YAML files directly. And in the text file collector, we are going to keep all our PromQL files depending on the resolution that we want, right? So in this case, we have for medium resolution, we had the output of our PostgreSQL wall prom file, right? And in the custom queries, you can edit the files to get the different information you want from PMM. So, yep, that's all. I will, send back to you, Chino.
Okay, cool. One question, Guli, is it possible to send more than one matrix on the same file?
On like the text file exporter?
Yes.
Yeah, you can send as many as you want, like as many as you can collect, basically. This is just, let me share again. This was just a quick example, but let me go back to the, where are my vectors? those fine collectors, text file collector, medium. Let's say that potentially this could be, if they were all different, this could be something like this, right? This name would be different, but you can have as many metrics here as you want, and PMM will collect them.
Okay. And how can
Correctly.
we check those metrics on PMM?
Yes,
Like,
that's a
let's
very
say
good
if I want to
question.
check those metrics, how can we do that on PMM?
That's a very good question. And let me share another screen. This is a mess. Customizing PMM, and let's go to our handy advanced data exploration.
How did you get that
Well,
window?
let's suppose we are on the home
On
directory.
home, yes.
You can click here and you can type anything you want, and
Okay.
you are going to, for instance, if you type Postgres, you're going to get all the Postgres dashboards you
The
have. In this
dashboards.
case,
Okay.
yeah, as you can see here, we had the table and the table statistics from Sergey and our own replication and wall size
The custom
dashboards.
ones.
Yeah, so we can just type the advanced data exploration dashboard, which will give us access to all our raw metrics that are being currently exported. So let's say we wanted to check our custom PostgreSQL wall bytes. We can click it, select the node we want, and in here we have the value as if it were seen as a gauge, and in here as a counter, because it may be one or the other, and you may want to see it as again one or the other. And this will help you realize if your exporter is being correctly sending data, right? And in here, if you hover, you will see that we have all the labels associated with that metric. Many of them are added by PMM itself, like the service, the node name, the machine ID, etc. And then others can be modified by us and added by us, like we did with service name.
Okay, cool. Cool. Those are the main questions we had here.
Yeah.
All right.